All right, guys, sorry, this is my second try on this one. My camera died. But today in our notes, we're going to add and talk about a new form of a line. This is called Slope-Intercept form. And this is probably the one that is going to look familiar to you from last year because a lot of teachers really like this one as their favorite. So they stress it a ton. So we're going to do that on page 57 and 58, Slope-Intercept form. In this video, I'm only going to be doing 57. And then in another video, I'll be doing 58. And then we might do that one together in class. So turn the page to 57, 58. On 57, we want to start here. So like I said, slope-intercept form is a different way to write an equation of a line. We want to know what the equation is telling me. So what's the information that the equation is giving me? And then how do I write an equation and how do I graph it? Okay. So as you can see, it's already a little bit done. Sorry. Y equals mx plus b is slope-intercept form. The reason that it's slope-intercept form is because there are two numbers that we're going to fill in. Firstly, m, which is still slope. M is always slope. And there are kind of two ways that we think about slope. We can think of it on a graph as rise over run. But more often than not, we're going to be finding the slope by using our slope formula from 2 points. So we'll be doing y minus y over x minus x to find our slope here. Unless they're super nice and they're just like, hey, the slope is 2. Okay, that'd be awesome. Now the b needs to be filled in with a number as well. And b is a very specific number on the graph. B is considered our y-intercept. So the y-intercept. Now, graphically, when I'm looking for the y-intercept, when I'm looking at my line, I'm going to look right for where that line touches your y-axis. So whatever that number is right there, like maybe in this case it kind of looks like it's at 1, that would be your y-intercept. But really it's a point, and so as a point, your y-intercept is always 0, some number. And it'll be 0, some number because to be right on the y-axis, that means I didn't move left or right at all. So the x value is 0, and I'm up some amount or down some amount. Now when I plug it into my my slope-intercept form, whatever this number is here just goes in for b. So like if it's 0, 2, then I'll put plus 2. Or if it's 0, -1, I'll put -1. So let's kind of go through and talk about the different ways we can write an equation, because that's one of the big things we need to understand. So when we write an equation in slope-intercept form, we always want it to look like y equals mx plus b, where m is going to be my slope and b is going to be my y-intercept. So the nicest thing that they can do for you is tell you exactly what your slope is and exactly what your y-intercept is. So maybe they tell you that the slope is 2, and then they show you that your y-intercept is at 0, -3. Well, if they tell me exactly my slope and exactly my y-intercept, I just put the numbers in where they belong. So we'd have y equals 2x plus -3, so really just -3. So no math needed there. They tell me exactly the numbers I need to put in, so I just put them in. If they're a little less nice to you, what they might do is give you the slope, so maybe -3, and then not give you the y-intercept. So they just give you some random point, like 1, 5. Sure. Well, if that's the case, if they give me a point and they give me slope, what I might do is just put it in point slope form. So on the last video that I posted for you guys, we talked about point slope form, y minus y1 equals m parenthesis x minus x1. So I plug in my slope and my x and y, so we'll have y minus 5 equals negative 3 parenthesis x minus 1. However, that's not the form they wanted in. But if I simplify now, which we talked about before, like we kind of wanted to simplify. If I simplify now, it will turn into y equals mx plus b, or slope-intercept form. So two things that I have to do to simplify is first, I need to distribute. So if we distribute the negative 3, we'll get negative 3x, and then negative 3 times negative 1 is positive 3. And then secondly, we need to get the y alone. So in this case, I'll need to add the 5 over. But if it was like plus 5, then I need to subtract the 5 over. So get y alone. In this case, we add 5, and I'm going to add it with the 3 since they're like terms, not the negative 3 because they're not like terms. And then I'll have y equals negative 3x plus 8. Now this is in y equals mx plus b form. And so yeah, now I can actually see my y-intercept. It's 8. I didn't even have to like know it. I eventually found it. Okay. If they're going to be really mean to you, then they won't give you the slope at all. They'll just give you 2 points, which is kind of worst case scenario. So let's say they give us the point 3 comma negative 6, and then the point 1 comma negative 3. Sure. I don't know how that's going to go. It could be terrible. If I want to write an equation in slope-intercept form, I need to know the slope, and I want to know the y-intercept. I don't know either. Neither of these points are my y-intercept because it's not 0 comma anything, and I don't know the slope. So first order of business is I got to find slope by doing my slope formula. So we'll find slope by doing y minus y over x minus x. So I could do negative 6 minus negative 3, but that will still be negative. So I'm actually going to go in the opposite order, negative 3 minus negative 6. And then I'll have to do y minus, or I'm sorry, 1 minus 3, x minus x. And so when I put my double negatives, we get a plus. Negative 3 plus 6 is positive 3. 1 minus 3 is negative 2. And yeah, our slope kind of is a fraction that doesn't reduce, but that's okay. All right. It's probably good. Okay, so now I have my slope, but I still don't have my y-intercept. But now I'm really in a situation like I was before, where they give me a slope and a point. So if they give me a slope and a point, I can put it in point slope form first. So that's what I'll do. I'll do y minus y1 equals m parenthesis x minus x1. This is why I like doing point slope form first, because if you already know it, finding stuff in slope-intercept form is much easier. Okay, so I'm going to pick the point 1 comma negative 3 to plug in just because I feel like it's a little easier. Because smaller numbers, they're both negative, so we'll have y minus negative 3, so really plus, equals m, which is negative 3 over 2, parenthesis x minus the x value, which is 1. The trouble is now I need to put it in slope-intercept form, so we have to distribute first and then get y alone. So we'll distribute here and get negative 3 over 2x. A negative times a negative is a positive, and 3 over 2 times 1 is 3 over 2. I'm running out of room. Because now I need to get y by itself, which means I need to subtract the 3 on both sides. And I'm going to subtract it with this 3 over 2. Now, 3 minus 3, that's just 0. So y is by itself, which is what we wanted. The slope is going to stay the same because I'm not combining it with anything. But then I need to do 3 over 2 minus 3. So it might be easier to think of 3 over 2 as 1.5. And like 1.5 minus 3 is negative 1.5. So still negative 3 over 2. And then you're in slope-intercept form. I can see my slope. I can see my y-intercept as not pretty as it is. And yeah, there you go. All right, last way we got to do it is talk about how to graph. So when I'm looking at the equation and I want to graph this, just like we did for point slope form, you have to have a starting point first. This time though, it's not just some random point, it's your y-intercept. So we're going to plot the y-intercept, or b, first. So in this case, because y is by itself, it's in y equals mx plus b. My b is 4, so my y-intercept is 0, 4. So on the y-axis, I can go to 4. Then, just like with the last one, we do slope as like rise over run, which in this case is 2 over 3. So we'll go up 1, 2, forward 3. And we could do a bunch of times, although it can't really go anymore this way. So instead what I'll do is down to backwards 3, just so we can get a really nice looking positive line. Oof. Okay, well this last one had to go and be sneaky. And I say that because this one is not in y equals mx plus b. To be in y equals mx plus b, the y really needs to be all by itself. And it's not. Like the 2x is over there with it. So kind of like I was doing over here when I had to get rid of this 3 and subtract it over, I need to get rid of the x. And it's positive, so I'm going to subtract it over. So I'm going to subtract the 2x, both sides. 2x minus 2x is 0, and so y is alone. Now over here, they're not like terms, so I can't combine them. I just want to write it in y equals mx plus b form. So we want the x to go first, so minus 2x. And then I want to scooch the minus 3 to the end. Okay, so kind of weird if it's not already in y equals mx plus b. But then I want to graph the same way we talked about. So we're going to plot b, or our y-intercept, which I can see is at negative 3. So 0, negative 3. And then, secondly, we want to do our slope. Slope is always attached to x. And in this case, it's negative 2 over 1. So from here, I'd go down 2, forward 1. And you can see how if I didn't put it in the right form, I would do the slope incorrectly, because this looks like it's positive, but it's really not. Like you have to have the y by itself to be in slope-intercept form. So then once we have a couple of points, we can draw a really nice straight line that is negative, as it should be. And yeah, there you go. Okay. We will do page 58 in a different video.